Solving inequalities. To solve an inequality, we need to rely on our graphs. And once we have a graph of representing the inequality, the rest of the work that we need to do will be just like when we solved equations, particularly systems of linear equations. So we're going to examine this inequality. It shows what looks like a linear expression on the left. It would be a line with a slope of 1/2 and a y-intercept of -2/3. And on the right would be the line y equals 2, which should look like a horizontal line. So if I were to graph the left side of the inequality as if it were a line, it would be this increasing line right here. And if I graph the right-hand side, it would be the horizontal line shown here. Then I can use the graph to make an interpretation as to which solutions will be making this inequality true. So what I'm trying to do is find numbers for x that will make the line have values larger than 2. On my graph, I can see that when x is bigger than this intersection point, that is, if x goes from around 5.3-ish or larger, that's going to force the values of the line to be greater than 2 as shown by the graph. So, step 1 in solving inequalities is to graph the left and right just as we did when we were solving equations. Step 2, use the graphs to figure out what the solution set should be. Now that we have the graph set up, we need to do the algebra to make sure that we get a precise value for our solution. The method that I'm recommending is ignore the inequality. Pretend it's not even there. So what I'm going to start doing is rewriting my inequality as an equation, and then I can go through the steps of algebra to solve that equation. As you can see here, I first multiply both sides by 6, so I can get rid of the fractions. I add 4 to both sides, and I divide both sides by 3, and I found that x is equal to 5 and 1/3. That's 5.3-ish. Now that I know that when x is 5 and 1/3, the left and right hand sides will be equal. That is to say, when x is 16/3, the left hand side will be equal to 2. I need to find out which values of x not make the left-hand side equal to 2. I want them greater than 2, and we've determined in our graph that if we increase from 5 and 1/3 the x values, the y values will be above 2. So all I have left to do is to take my algebra and convert that to a solution to my inequality. In this case, it says if x is any number from bigger than 5 and 1/3 and beyond, then the inequality will be true. Another example of this, then, would be to solve the inequality when 2x minus 4 is greater than 3 minus x. The 3 minus x is a line with a decreasing slope, a negative slope or a decreasing line, and the 2x minus 4 is the increasing and steeper line. So all I have to do is take my graph and make the interpretation that when x is bigger than, it appears to be around 2 and 1/3 maybe, when x is bigger than 2 and 1/3, the values of the increasing line will be larger than the values of the decreasing line. Once the graph is established and the solution is predicted, we turn the inequality into an equation. I do my algebra, add x to both sides, add 4 to both sides, divide both sides by 3, and that shows that 2 and 1/3 is in fact the solution to this if it were an equation. In order to find the values that make the inequality true, I need to go from y or x equals 2 and 1/3, including 2 and 1/3, all the way up to infinity. So any number bigger than 2 and 1/3 will be a solution to this inequality. And you can verify that by substituting numbers in for x. Like 3. 3 is bigger than 2 and 1/3. That gives us 6 minus 4 should be bigger than 3 minus 3. 6 minus 4 is 2. 3 minus 3 is 0. 2 is bigger than 0. A final example. This is what's called a compound or nested inequality. I need to find out when the values of x plus 5 are smaller than 4, but at the same time bigger than 2. My graph shows the line y equals x plus 5. My graph shows the horizontal lines for y equals 4 and 2. And my graph shows the intersections appear to be at -1 and -3. So I'm going to guess that my solution set will be numbers bigger than -3 at the same time smaller than -1. As for the algebra, I take the inequality, remove the inequality signs, and turn them into equals. But then I can break up this particular equation into two. Here's the first equation, y or 2 equals x plus 5, which I wrote separately over here. And here's my second equation, x plus 5 equals 4, which I wrote here. And you can solve each of those individually, find the values that correspond to your graph, and everything's coming up roses. So the solution set is any number including -3 or larger and less than -1 will be the solution. So when you see inequalities of your own that look like this, again, we look at this as a line, we look at this as a horizontal line, and we try to find out which values of x are going to make this number smaller than -16, for example. So try some on your own, and good luck.